All right, so our goal today is we're going to determine the roots of a quadratic using the quadratic formula, and our goal is to leave our answers in exact form. So you've heard me talk a little bit about how in grade 11 we're aiming toward leaving things in fraction form as simplified radicals, and that will allow us to not have any rounding that we have to do, and it allows us to express our answers in like a perfect format and an exact format. So that's kind of our goal. So when we say the roots of a quadratic, what are we talking about? Declan? Yes, we're finding the x-intercepts. So we're kind of just expanding on, we did a review of the quadratic formula a few days ago. We're just going to expand on that with our new knowledge of radicals to see if we can simplify but leave it in an exact format. Okay, so no decimals, they're in fraction and radical form. All right, so as you guys remember from a few days ago, anytime we use quadratic formula, we need the equation set equal to 0 on one side before we start finding x-intercepts. Okay, this one is in the correct format, so we can go ahead and identify ABC. Just a reminder for you guys as well, A is the value in front of x squared, B is the value in front of x, and C is the constant value or the value that doesn't have an x with it. So we usually try to write this in descending order. So it will be like x squared, x to the exponent 1, and then the constant. Okay, so I will write quadratic formula once here so you guys have it. I'm not going to write it for the other two examples though. Okay, and then we're just going to plug in. You're going to simplify as much as possible, so simplify any negatives out here, simplify inside your square root. So I think we get 100 minus 60, right? So 40. Great. All right, that's our grade 10 part. And usually in grade 10, and what we did a few days ago was at this point we would break it up into the plus option, the minus option, and we would calculate it. But with our new grade 11 knowledge, now that we know about radicals, we're going to try to leave this as exact x-intercepts or exact answers. So let's look at the root. We can simplify this root. We've got root 40. What's the biggest perfect square inside of 40? 4 and 10 works, so we're going to split that up into 4 times 10. So, Sophia, 100, 10 squared, minus 60. You okay? Okay. Did you forget to write 10, the negative 10 squared? All right, square root the perfect square part of this, we'll get 2 root 10. Okay, once you have fully simplified your root, you're not going to touch the root anymore. So my final answer, if I do this correctly, should still have a root 10 in it. Okay? Make sure that obviously there's no more perfect squares left inside your root, but if you did find the biggest perfect square inside your radicand, then when you simplify, your new radicand shouldn't have any more perfect squares that are factors inside. Okay, so we're just going to look at this right here, 10 and 2. Can I take out a common factor from those two things? Do they share anything common? Okay, so we'll take out a 2. We'll open a set of brackets, and we have to write what's left. So 10 divided by 2 is 5. And the 2 here, just that will cancel once we divide out the 2, so we're just left with root 10. Okay, and now I can reduce. So 2 and 6 we can reduce, it will be 1 and 3. When I have a 1 outside a set of brackets, I don't really write a 1 outside of the set of brackets, just like we don't write 1x. So if this happens to be a 1, you can just remove it and drop the brackets off. So we're just left with 5 plus or minus root 10. So here's our x-intercepts. The first one is the plus option. The second one is the minus option. And this is how we're going to leave our answer. Okay, these are the x-intercepts in exact form. So technically, if we write these as points, we're looking at 5 plus root 10 over 3, 0, right? Because this is where the y's are equal to 0. And the minus option, comma, 0. Okay, any questions on this one? So the nice thing about this is that if you get to this point right here and your root can't be simplified, you can end it there. You can just split into your plus option and split into your minus option. Okay, because we know not all roots will end up having factors inside that are perfect squares. So potentially you could even stop here if your radicand doesn't have any factors that are perfect squares. Okay, can I scroll? Are we all good? Okay, just going to try a couple more and then you guys will have some time to practice. All right, so find the exact solutions. We are not quite in the form to be able to solve this quadratic though. What's wrong here? Here? So we have to move this over. Okay, and then you can list your A, B, and C. And I'm just going to plug directly into quadratic formula here. I'm not going to recopy it again. You guys have it above. Okay, guys, one really big thing that I see a lot is that people don't extend this line all the way through from the first term here to the root. I see a lot that people will write just the root part over 2a, and that's actually not correct. We want to make sure the entire numerator, this whole thing right here, is all divided by 2a. So please make sure that that line goes all the way from left to right. Okay? All right, let's simplify this a little bit. We're going to get, what, 64 minus 40, so 24. Okay, now into the grade 11 part. So does 24 have any perfect squares inside of it? Lisa? Great, 4 and 6. We will square root the 4 part. So square root of 4 is 2, 6 remains in the root. Okay, we're going to take a look at negative 8 and 2 and see if there's a common factor. Now, one thing that I always look out for is if this term is negative down here, I like to also common factor a negative from the top because usually we don't write fractions with negatives on the bottom. Like if I have something like 1 over negative 3, we really more so just write it as like negative 1 over 3. So We don't really like to write negatives in denominators, technically. So anytime you see a negative on the bottom, I would also common factor out a negative from the top so that you can cancel those things. So out of negative 8 and 2, what would we common factor? There? Yep. So we're going to common factor negative 2. Only mostly necessary if you have a negative on the bottom. However, if you want to common factor a negative when this first term is negative, you can definitely do that. Okay, and then we're going to write what's left. So negative 8 divided by negative 2 is 4. And we remove the negative 2 here. Now the interesting thing here is that we have plus minus. So when I divide out a negative, I really just get minus and plus back. So the plus minus really just stays there because both terms change signs. So we still have a plus minus in between. And then we just have root 6 left. Okay, so the negatives will cancel each other. And I can reduce 2 and 4 to 1 and 2. Kira.
Explain the negative thing again, like how if you're doing negative 2 divided by 2, like negative 1 doesn't happen.
Sorry, ask that one more time.
So like on the bottom step on that side, it's like you're taking negative 2 out.
Yep.
But there's a 2 there, so does it become negative 1, or is it just the same?
So yes, so technically there's a 1 right here, right? But we don't really write 1 in front of things. And then the plus minus, if you think about them individually, if I take out a negative from a positive, I will get a negative. So your plus will become negative. But I'm also taking out a negative from a negative, so that will become a positive. So I still have plus minus there. Okay, sometimes just like for your sake, I will like write it as minus, like minus plus here, so that you guys can see the positive change to a negative and the negative change to a positive. But we don't really write it like that, but that's kind of what happens. Okay, so you can write your x-intercepts. One of them is the plus option, one of them is the minus option. Any questions? Any other questions on that one? Everyone's good? Can I scroll here? Okay, last one. Okay, so we want to find the exact solutions or x-intercepts here when this is equal to 0. You're going to plug this into quadratic formula. All right, so we're going to get 16 plus 36 here, so you should get 52 under your root. All right, so we need to find the biggest perfect square, if any, inside of 52. Really? Yes, 4 and 13 fits. Good job. And we're going to square root the perfect square part. The rest stays under. Okay, once you've done that, you leave that root alone, okay? So no, like you don't common factor out of from underneath a root or anything like that. We're just looking at the numbers that are outside of the roots. So the constant and the number in front of the root. What can we common factor from 4 and 2? Sophia? 2. So we're going to take out a 2. We'll write what's left. So should be 4 divided by 2 will give us 2. And I took out a 2 from 2 root 13, so we're just left with root 13. So 2 and 6 can simplify to 1 and 3. So there's our solutions there. Okay, so in some of our examples here, just so you guys are aware, most of these guys just simplified to 1 right here, which is why we were able to just drop the brackets. That's not always going to happen. Sometimes like it might simplify to 3 and something else. So in that case, if this simplified to 3 once you reduced with the bottom, I would maintain those brackets and just keep that value out front. So you can keep it common factored, you don't have to put it back in or anything like that. So that's just one little thing that you should be aware of. Also remember, if at this point you decide that that root can't be simplified, if there's no perfect squares inside, you're going to split it into the plus option and the minus option and go to this. That's done at that point. Okay? Also, if you guys want to avoid having to do this bottom part where the bottom is negative and then common factoring out a negative, make sure your A value is positive. So in this case, if I wanted to avoid having to like common factor out a negative and like figure out this whole like negative deal, I just don't want the A value to be negative because then the bottom will become negative. So instead of moving the 5 over, we could have actually moved the 2x and 8x over to the opposite side. And you can enter it in like this as well. So if your A value is not negative, you don't have to worry about like, do I common factor a negative, do I not? So if you always make the A value positive by just moving everything to the side where A would be positive, then you won't have to worry about common factoring the negative. Okay? Declan?
If your root doesn't have any perfect squares, are you still expected to reduce it to the least? Like reduce the other numbers of the
So let's just say like this, for instance, if we weren't able to reduce the root, I can't reduce this because I can't reduce anything from this term. So you can only reduce if you can common factor from both terms on top. Okay, this is equal to what we talked about before with crossing out the 4s because you're only reducing from a single term. But this root 24 is also over 4, right? So you can't just say, oh, it's 4 and 1 now, and now the 24 is, like I haven't reduced anything from that, right? So, yeah, good question. Okay, any other questions? Okay.